Hello and welcome to video 24 of Flipped Geometry. Right, so we are on to the last prism that we're going to discuss in this series, and that's the cylinder here. We've already spoken in previous sections about the surface area of a cylinder. We've done a lot of work working with circles and understanding pi and the area of a circle. So today we're simply looking at the volume, in other words, the space inside of this cylinder. Because it's a prism, because it has those two identical bases and it has that big H distance between them, it still follows this same formula. It still follows this idea that the volume is the base area multiplied by big H. So the only difference now is we have a circle as a base. So instead of writing any base formula, I'm simply going to take the formula for a circle, which we know as pi times the radius squared, and that's going to get multiplied by big H. Okay, now we've got a volume formula for a cylinder. Let's put some numbers into this and try to make some sense of the equation itself and the calculation itself. Let's say that we have a big H distance here of 10 meters. That's a 10 there, it should be a closed zero, there we go. Let's say that's 10 meters, and let's say our radius here is 3 meters. So we've got 10 meters big H, we've got a radius of 3 meters. So, let's now use our formula, put some numbers in here. So we've got pi and the radius squared. So our radius is 3, and that's going to be squared. And all of that is going to get multiplied by 10, which is, of course, our big H. We have to work inside the parentheses first when we're doing this, and then PEMDAS tells us, is there any exponents? In this case, there is, so we have to do the 3 squared first. Remember, with exponents, it's not 3 multiplied by 2, but 3 multiplied by itself. So in other words, 3 times 3. So inside the parenthesis here, I get 9 times pi, or pi times 9, as I've written it here. Okay? So we've got that, still multiplied by 10 on the outside. What I'm going to do now is, because this is all multiplication, pi times 9 times 10, I can actually do the 9 times 10 before I multiply the pi. So what I'm going to end up with here is pi times 90. Okay, so the volume of this shape is pi times 90. Now at this point I can go two ways. I can either calculate this by hand using pi as 3.14, or I can take a look at the calculator and see what the full pi will give me. And what I can do then is compare the two answers and see if I'm satisfied with the abbreviated version, the 3.14 version, if it's close enough for what I'm trying to do. So what I'll do in the video here is do both ways. So let's start just with the 3.14 version. So over on the side here, I'm just going to do a quick calculation. So I've got 3.14 for pi. I'm multiplying it by 90. So I'm going to set it up just like this. Now, because I've got a 0 there, of course, I'm just going to skip to that point there. So 9 4s, 36, that's 12, carry a 1, 3 9s is 27, and 1 is 28. I've got 2 places of decimal, so I'm going to end up there. 282.60. So my one option is that the volume is 282.60 meters, and you guessed it, meters cubed. Okay? So that's one way, if I was to do it by manual calculation with 3.14. If I was to do it with my calculator here, I would simply go 90 multiplied by, and shift and put pi in there, and the calculator will tell me that the answer comes out to be very similar. It tells me that the answer is going to be 282.74, and I'm rounding it slightly to just 2 places of decimal, but 0.74. So that's the calculator version. Oh, forgot something. The units, of course, is still meters cubed. So in the end, I have two ways of looking at this, and you can see a slightly more accurate version here with the calculator, slight difference in the decimal. The 282, the whole number section, is still the same. Regardless, both give me a volume of approximately 282 cubic meters for this cylinder example.